Hi guys. This video is going to cover the second part of the notes on this particular note taker. If you have not done the Associations of Scatter Plots notes yet, and you haven't done the practice page that goes with the Associations of Scatter Plots, stop this video, go do that, and then come back. If you have done both of those things, then we're going to be talking about lines of best fit and trend lines for scatter plots. And I'm going to give you an example of how to do that in this note taker. Now we're moving on from lesson 14.1 to 14.2, and this section of the note taker is going to help us answer the question, how can you use a trend line to make a prediction from a scatter plot? Okay, so what we're going to be doing is we're going to be looking at scatter plots. We're going to draw a line that kind of follows the trend that the scatter plot is following, and then we are going to use that line to make a prediction. Okay, we're still on page 149. So if you want to fill that out in your table of contents, please do. All right, so a line of best fit or a trend line looks something like this. I have some data that is representing a positive association, because as that X is increasing, the Y is also increasing in each of our data points. Of course, there's going to be some outliers like this one right here that are further away from the trend line that we created, or further away from some of the data. But what we can do is we can create a line that goes through most of the data. And the way that we can do that is by doing what we've done before with slope-intercept form equations. The first thing that you're going to do is you're going to find within a set of data 2 points on the line with exact values for X and Y. So if I'm looking at the line that was drawn through all of these different ordered pairs, I'm going to find a part of the line that goes through 2 exact coordinates. Now, I'm not looking for data points that it goes through. I'm looking for a point, a part of the line where it goes through that coordinate. Also, before we do that, notice I have the same number of data points, 1, 2, 3, 4, above the line as I do below the line, so that makes this a reasonable line of best fit. Okay, so if I'm coming up with the points, I might choose this coordinate right here, because that is 0.22. You can see if I follow it up and over, that's an exact point. Now, it's not one of my data points, but it does lie on the line. Another exact point might be, it's kind of hard to see up at the top here, but I'm thinking probably 9, 10. If I go up and over, yeah, 9, 10 is a good exact point. So I've identified 2 different points on that trend line. I'm then going to use those points to find the slope of the line. Now, it's been a while since we've done that, but I will refresh your memory on how to find the slope, given 2 points. The equation that we use to find the slope given 2 points is m equals, m meaning slope, y2 minus y1 over x2 minus x1. And the y and the x come from the points that are represented on our graph. Okay, so if I look at my 2 points, 2, 2, and I'll just rewrite them over here, 2, 2, and 9, 10, I have an x and a y value for each of those. We call this x1, y1, because that's the x coordinate in our first set. The y is our y coordinate in the first set. So then this one is x2, y2. Now that I've identified that, I can plug it into my formula. So y2 is 10, y1 is 2, I'm going to subtract, over x2 is 9, minus x1 is 2. So if I subtract that, I get 8 over 7. We can leave it just like that. That's going to be our slope. Okay? The second thing that I'm going to do is I'm going to find my y-intercept. My y-intercept is where it crosses that y-axis, and you can see here on the graph the y-intercept is right at 0. So we have a y-intercept of 0. So then what we're going to do is we're going to write our equation. Our equation is in the form y equals mx plus b. So m, if m is our slope, my equation will be y equals 8/7 x, and if b is my is 0, I could add 0 or I can just leave it. So I'm just going to leave it. Right there is a good equation for the graph that I have, or my line of best fit here. So now I have an equation. I can use that equation to then make a prediction. Okay? So here it says, use the trend line to predict how many umbrellas would be used over 30 rainy days. Now I know days is represented by X, Y is umbrellas. If I plug in 30 for X for the 30 rainy days, I can figure out about how many umbrellas I would need. So 8/7 times 30 equals, so I can plug this into my calculator, 8/7 times 30, so that gives me about 34 2/7. I'm going to round it to the nearest umbrella, so since I'm not quite halfway, I'm going to say it's about 34 umbrellas. Okay, so that's how I can use a trend line to make predictions. So even though that this data doesn't go up to 30 days, we can use the graph to come up with the equation for the line to then predict how many umbrellas about they would need over 30 days. Okay. Now we go over here, it says explain that's a typo, how you know your equation is a reasonable representation of the trend line. I talked about that earlier, and that was that there's the same number of data points above and below the line. Okay. And then over here, we're just going to finish up with a statement. We can predict that about 34 umbrellas will be used over 30 rainy days. So what we did was we were able to look at a trend line that had the same number of data points above and below the line that represented the association presented in a scatter plot. We then were able to come up with an equation by finding 2 points on the line to find the slope and the y-intercept to come up with my equation. And then we were able to use that equation to predict how many umbrellas would happen after 30 days. So we're looking at making predictions based on this particular trend line. Okay. We'll continue working on this tomorrow when I am back. But until then, please make sure you have your notes for association, line of best fit, and then the practice page for association completed before I return on Tuesday. See you later.